I want to talk to you about the vertex of a parabola. This is one of the most important concepts from chapter 10, in my opinion, from quadratic equations and expressions in general. When we were looking at the shape of a parabola, it fell into one of two major categories: parabolas opening up and parabolas opening down. Now, for both of these instances, this parabola had an extreme end, sort of an extreme point, either the bottom of the valley, if your parabola was opening upward, a minimum point, or lowest point, and if the parabola opened downward, it had a highest point, it had a top of the hill. So the vertex is the term that we call this extreme point. The vertex of a parabola is its highest point if the parabola opens down, the top of the hill, and it's its lowest point if the parabola opens up, and it's the bottom of the valley. The extreme point on the parabola is called the vertex. So what I'd like to do is I would like to find or locate or indicate the vertex of the parabola that's graphed here in the corner. This parabola opens up, so I'm looking for the bottom of the valley down here at this location. Now this is a bit hard to see. This is the x-axis. This is the y-axis. This point is located at 3 in the x position, and it's located, it looks like one down on the y-axis, -1 in the y's position. So the vertex of this parabola is the point 3 minus 1. Be careful. The vertex is a point consisting of two numbers in an ordered pair. It's not ever a single number, and it's not ever a list of individual numbers. It's a point. It's an x and a y. Vertex. Okay, now let's see some of the sneakier ways that someone can be referring to the vertex without necessarily us realizing it. Let's take this example. The quadratic equation y equals standard form has a graph that opens down. Now I want to take that piece of data and make a quick note here. This parabola opens down, so the vertex would be located right up here. It says the maximum value of y is 13. The x value at which this maximum is reached, that x value is 2. What's the vertex? Now the key to this problem is to realize that for a parabola opening down, every time they're talking about maximum, they're referring to the vertex. They're referring to this highest point, this point where the y values, the heights, are as big as they could possibly be. Maximum y value. Maximum referring to vertex. Now let's see, the vertex has a y and an x coordinate. So let's try and appropriately position this 13 and this -2. What is your first thought? You're going to position that 13 into the vertex. Would that 13 be an x value or a y value? We read this carefully. It says the maximum value of y is 13. The value of y is 13. Since the value of y is 13, that indicates that 13 is the y coordinate of the vertex, the maximum y. In the second part of the sentence, it says the x value is -2. The x value is -2. So -2 would be the x coordinate of the vertex. So be careful Maximum and minimum are keywords that are usually signaling the vertex in there somewhere. All right. Now, if you have an expression or an equation in standard form, ax squared plus bx plus c, there's a very nifty way to calculate the vertex. And you usually start by figuring out what the x is. The x for the vertex, which I usually call xv, to say this is the x of the vertex, can be calculated by taking negative b, so whatever b is, flip the sign, and divide that by 2 times a, 2 times whatever this number is. So you'll do that calculation, you'll find some number, and then to find the y value of the vertex, all you have to do is plug in the xv that you've just found. Let me demonstrate with this particular example, 3x squared negative 6x plus 1, where a is 3, b is negative 6, and c is 1. It says that xv is negative b over 2a. In our case, it would be negative 6, negative b over 2a, 2 times 3. So be on the lookout. One of these negatives came from the formula itself. This 2 came from the formula itself. And the 3 and the negative 6 came from our particular equation. So let's clean that up. If I simplify it, it says xv is 6 over 6, and therefore xv is 1. How would I then find the y-coordinate of the vertex? All I have to do is take this x value, plug it into this formula, and say what would happen if I did 3 times 1 squared minus 6 times 1 plus 1. This works out to 3 minus 6 plus 1, or negative 2, and that's the y value for your vertex. So my final answer to this question would be the vertex is the ordered pair, the point where x is 1 and y is negative 2.